Hello dear students, in this lecture we are going to discuss whether you should challenge question number 25, question number 53 and question number 55 of GATE 23 Mechanical Engineering. If you are only confused about one question or two questions, no need to watch the entire lecture. You can use these timestamps to directly jump to the exact question of which you want to see the explanation. Let's begin. Starting with question number 53. Now, whenever I discuss any questions, especially to teach concepts, I explain even the question in very much detail because each and every word of the question is important. But here, I am not explaining these questions, right? I am not right now trying to teach you the concepts. Right now, I am only going to very logically and conceptually tell you why you should or should not challenge a question. That's why I am not going to discuss each and every line of the question, and I am sure by this time you have gone through such questions 10 times. So you already know what question has mentioned, what it is asking. I'll just pinpoint specific words of the question as a result of which it could be challenged or could not be challenged. Question is saying to find out the dimension C here with all the given information to be considered under 6 sigma process. 6 sigma process. Upper limit of dimension C should be how much? Upper limit. Okay. Now here it has mentioned 6 sigma, as a result of which many students are thinking to challenge it on the basis of this question being out of syllabus. Now at this point of time there are two questions which we should discuss. Only after that you can decide whether to challenge or not challenge. Question number 1 is it actually out of syllabus? And question number 2 is that if it is out of syllabus, can you solve it using the concepts within the syllabus? You got the two questions. Is it actually out of syllabus? And if it is, then can you solve it, the question, by using the concepts which are into the syllabus? These two questions and their answers will help us in deciding whether to challenge or not challenge. Question number 1 is whether this topic of 6 sigma is in the syllabus of GATE Mechanical Engineering or not. Answer is it is not. It is out of syllabus. It is in GATE PI, but it is not in GATE ME. In fact, if you pick the official syllabus provided by IITs, you will very easily find it that 6 sigma is mentioned in GATE PI, but it is not mentioned in GATE Mechanical. Due to which you have a good chance that you can challenge this question on the basis of this question being out of syllabus, or this topic of 6 sigma being out of syllabus. I agree to that. Even I want that such questions should not be given in GATE which are from the topic which are out of syllabus. So on this basis, you definitely can challenge it. Nobody can stop you to challenge it. Point is, will IIT accept such challenges of out of syllabus? The chances are less, as I have already told you. Especially in this question, I will tell you why. Look, if a question is out of syllabus, drastically out of syllabus, there can be chances that GATE can accept the challenge that yes, it is out of syllabus. But you will see that in this question, actually the concept with which you are going to get the answer is not that out of syllabus. So that is why I am saying that in this question, the chances that this question's challenge would be accepted are slightly less. Should that stop you from challenging? I think no. You should challenge it, right? If you feel that you're out of syllabus question they have given, this is not the ideal situation. It should not happen. Definitely you can challenge such questions. By mentioning that this is out of syllabus, you can upload this screenshot of GATE Mechanical. You can prepare a Word file. This is the syllabus of GATE Mechanical. Put the screenshot, especially the part of industrial and operational research, that part. And then you upload the screenshot of GATE PI syllabus where specifically there is a unit of quality control under which there is a topic of 6 sigma. And you can say that this is not in the syllabus of GATE Mechanical Engineering. This is the reason which I want to challenge this. In that situation, marks to all would be given in this specific question. On that basis, definitely you can challenge it. I want IIT should accept it, although I think the chances of this challenge being accepted is slightly lesser. Why? Let me tell you. That is related to question number 2, that if it is out of syllabus, can you solve it using the concepts within the syllabus? Answer is yes. you will get exact 16.5 answer. The range for this question is given as 16.4 to 16.6. Let me show you the solution. You will get exact 16.5 as the answer using the concepts within the syllabus. No rounding off required. Exact 16.5. So the first thing here is that you require the dimension of C, upper limit of C. I will talk about that, whether upper limit word is correct or not. I will come to that. But C is equal to D2 minus D1, correct? That's what you can write. Here you have been given individual standard deviations of D1 and D2, right? D2 follows a normal distribution with mean value and standard deviation of given value. Similarly, D1 also has been given mean value and standard deviation. Since standard deviations are mentioned, look, some students were trying to solve this by the concept that maximum value of C would be maximum value of D2 minus minimum value of D1. That you can do when tolerance has been given to you. Specific tolerances have been given. This question has not given you tolerance, it has given you standard deviation. That's why you need to use the concept of variance and standard deviation in this question to find out the dimension of C. So I hope this clarifies some students' doubt that why maximum value of C we are not calculating by maximum value of D2 minus minimum value of D1. That's the reason. Coming to this expression, applying the variance here, you are going to get this, right? Now here, let me tell you one thing very important, that you must know the properties of variance and standard deviations. Those have been already discussed in engineering mathematics course, right? So finding out this expression, the variance of this expression was very much possible using the concepts of engineering mathematics. Here again I am not explaining all these things, but from the property of variance we know that this minus can come as a coefficient with a square, right? This property also has been discussed in the course. This minus 1 square would become plus. So this is what the variance expression is going to become. This expression has been wrongly done at almost every place. Let me be very clear here. So far, no other place where you can find the solution has solved it correctly. Even the variance expression has been written incorrectly. That is why I am sure by now you have not got the correct answer. Don't worry, in few minutes you will see how you can get the answer. Now writing the variance in terms of standard deviation. So this is what you can write, correct? Standard deviation square is equal to variance. Put the value. You have been given the values of standard deviation of D2 and D1. If you put those values, easily you can find out sigma C, correct? Because this is Pythagoras triplet 0.3, 0.4 square. Overall root if you add it 0.5. So sigma C is 0.5. You have got the value of sigma C. Now comes a very crucial part. You have got the value of sigma C. The mean value for D1 is 20 and the mean value for D2 is 35. So mean value of C would be D2, mean value of D2 minus mean value of D1. So 35 minus 20, which is 15 mm. So this is the mean value for C, 15 mm. And standard deviation is 0.5. Now second step comes, where again many other places have solved it incorrectly. The correct expression here to be used is mu plus 3 sigma and not 6 sigma. Why? You may think, sir, question has mentioned 6 sigma process. It should have 6 sigma on this side also, on that side also. Again, I will like to bring your attention to a keyword in the question, which is rather two keywords. One is the process control. And even if you look at these details, it is telling you that how much is the standard deviation and mean value in the process when D1 and D2 are measured, right? Their dimensions are checked. There are two things which are very important in 6 sigma discussion. Again, now I am talking about things which are slightly out of syllabus. It is possible that you may not fully understand what I am telling, but still try to listen for 1 minute. Process, whatever process you are conducting, that has a standard deviation which we generally consider in under process control, correct? How much general standard deviation it can have, and that upper and lower limit is decided by plus 3 sigma and minus 3 sigma for a process, correct? Under 6 sigma, things change slightly because you try to do everything within the specification that customer has asked you. Whatever process you are conducting has two set of limits. One is specified by the customer, that this is the part that I want and its dimension should not be more than this, should not be less than this. So that's the specification which is given by the customer. That's the voice of your customer. So it has upper specification limit, lower specification limit, in which there will be entire 6 sigma on one side, 6 sigma on the other side, right? Almost 99.99996%. But whenever you are conducting a process, that process capability and the control in the process is of plus minus 3 sigma. And that is denoted by upper control limit and lower control limit of the process. That's what is controlled by the process. That's why process width is plus 3 sigma and minus 3 sigma only. Question is talking about, question has nowhere given you the specification of the customer. These details which are mentioned here are not the specification by the customer. They are the variations within the process itself. Even here also it is asking about the process control itself. Nowhere question is mentioned that you have to find out the upper limit which is specified by the customer. Even if you look at the statement, the machining process making this part is known to be statically in control based on sampling data. So the data that has been given to you, the sampling data that has been given to you is of the machining process itself, not the data which is required at the user specification. That is why even though it is a 6 sigma process, these details will be of plus 3 sigma and minus 3 sigma. Upper limit is going to be plus 3 sigma only, because it is process control in which you are talking about the actual process happening and the total deviation in the process, not talking about the user specification. And hence if you put the values here, you will get the value of mu as 15 and 3 sigma value, sigma is known as 0.5, you solve it, you will get exact 16.5, which is exact midway of 16.4 to 16.6. Now comes the point, is this out of syllabus exact expression? No. For a process control, we know that mu plus 3 sigma is going to give us the upper and lower limit. Even though question is talking about 6 sigma process, but it has given you the process, it is talking about process capability only. Process capability is something that we already cover, that we discuss. Plus 3 sigma, minus 3 sigma from the mu values, this is something that we discuss. So although the topic is out of syllabus, 6 sigma it has mentioned, means it is out of syllabus. But the solution of this question can be purely done by the concept of mathematics and by the concept of process capability that is there in gate mechanical syllabus. So that is why this brings us to question number 2 that I asked, that if a question is there which actually is from a topic which is out of syllabus, but it can be solved by the concepts which are absolutely within the syllabus, can this be challenged? So this is debatable now. Question number 1 was not debatable. Question number 1 is very much clear. By 6 sigma is out of syllabus, it should be challenged. That's the clarity that question number 1 has. Means question number 1, I am not talking about some other question. This question also has 2 sub questions. As I told you, is it out of syllabus? Yes. Should you challenge on the basis of that? Obviously yes. Now will that challenge be accepted or not? That's up to IIT. But especially because this question can be solved from the concepts within the syllabus, that makes it even more debatable whether IITs will accept this challenge or not. Genuinely, who teacher would want that out of syllabus question should be there, right? Such questions should not be there. There are so many thousands of concepts within the syllabus, very good concepts also. So if IITs want to make good question, they should consider topics from within the syllabus. Na? Why to pick such topics which are out of syllabus? Good questions can be framed, very good questions can be framed within the syllabus itself, which many students would not be able to solve. But to pick such questions which are out of syllabus, it is just not acceptable. But the reality, if you challenge, there is no surety that it will be accepted, especially because the concepts which are used to solve this question are within the syllabus. So it is up to you. If you are okay with wasting 500 rupees, if it is not accepted, then you should challenge it. But if you think, nahi, I'll be very sad if 500 rupees are gone, then don't challenge it. Okay. But ideally, I think it should be challenged because of the topic being out of syllabus. Even though, let me be very clear, here I have told you exact concept and the exact answer. At this point of time, check anywhere, no one has solved this question with the exact answer. So even though I have told you the exact answer, I can tell कि don't challenge it. I have told you na answer देखो, it is within the syllabus, don't challenge it. But still I understand that it is not a good thing that if I have solved it, then I will say that no, don't challenge it. Even though I have solved it, still I am telling you that this topic as such 6 sigma is out of syllabus. On that ground, you can challenge the question. Coming to question number 25. Again, this is a question where language of the question is something where students or different institutes, you can say, are debating. I'll tell you one thing very clearly. This is not a very good question. The language of the question is obviously poorly framed, but still I think if you think conceptually and logically, you will get your answer. In fact, Exergic was the only institute who told you the correct answer of this before the official answer, right? Already we gave A, B and D in our answer key, same as the official answer key. But still I can understand why some of the students may be confused in option C. So that I will tell you here, that is that valid confusion? Can you challenge the question on the basis of that confusion or not? Quickly I will tell you, I will not go into the details here. We all know the details of casting, and these are some very basic concepts of pattern and mold and molten material, right? So I'm sure you know the concepts. None of the students would not be knowing the concepts, right? But they just could have got confused in the language of the question, right? That's why I'm saying, even though we were the only one to tell the answer correctly, we can say, so easy question, others are not able to solve such easy question. But that's not the reality. Language of the question, I understand, is confusing. That's why many of the students as well as institutes could not solve this correctly. The first thing to note in the question is that nowhere question is talking about wall of the box, the casing of the casting. It's only talking about pattern, it's only talking about mold, and yes, sometimes it is talking about the molten material. That's it. So only focus on these 2-3 things. Don't look away from that. Don't start looking at what will happen when you have the box in which the sand is getting filled. And who told it sand casting? Where question has mentioned it is sand casting. It simply says a metal casting, right? So that's why I don't always think from the perspective of sand casting that you will have a such casing where in which sand is getting filled. That can confuse you, especially when mold wall will be discussed, because mold wall, some part will be towards the cavity, some part will be towards the box, towards the casing. Question is not talking about casing and all. Where has it mentioned? So forget about that part. That will reduce 50% of your confusion. Only focus on pattern, only focus on the cavity, mold cavity and the molten material. Got it? That's one thing that I have seen students getting confused in, so I clarified that. Moving ahead, let me give you a simple example of casting. This is a pattern. If you have a pattern, the wall of the pattern is simply the pattern wall, correct? What you are going to do, again, let's take the simplest case of sand casting itself, not considering the casing and boxes, only the pattern, mold, only these 2 things we will be looking at. So this is the pattern, this is the wall of the pattern. You filled the mold material, right? So it may look something like this, right? The mold material has been filled around the pattern, okay? Only one lower half I am showing, upper half let's say I am not showing. And then you removed the pattern. So what will you have when you remove the pattern? This is going to be the mold wall. Now there will be no confusion regarding the mold wall, right? Those of you who are looking away unnecessarily, where question has not mentioned anything about the casing, about the box, might have gotten confused. So only focus on this. This is the mold wall. One more confusion here students can have, that whatever is going to be the shape of the pattern, right? Look here, this is the pattern wall, right? The dimension of the mold wall will be almost identical to the wall of the pattern. Dimension, listen to me very carefully. Dimension of pattern wall and mold wall will be identical, right? So why question has given you pattern wall and mold wall 2 terms? It could have said any one wall, right? Why? Because think logically. Logical conclusion I am telling you, after which there will be zero confusion in the question. Pattern wall can be defined when you have a pattern. If I have a pattern, I'll say this is the pattern wall. And when I don't have the pattern, when I have mold cavity, then that is the mold wall. That's it. Pattern presence will make pattern wall discussion relevant. If pattern is not there, if I have this situation, Does it make sense to talk about pattern wall? Arey bhai, pattern is gone now. Pattern is no longer there, yaar. Only mold cavity is there. So now you will only talk about mold wall. Right or not? These two things, if you understood, there will be no confusion in the question. B and C options, B and D options are clear, so I am not discussing that. As I told you, I am not telling everything from zero concept here like I do generally when I solve questions, when I discuss question. I am assuming that you have gone through the question, you know the concepts. So I'm not discussing concept, I'm only discussing the part which can confuse you or which can make you challenge or not challenge the question. Part A is saying mold wall indicate boundaries within which the molten part material is allowed. It is talking about firstly mold wall, means this is the situation which it is talking about. When mold wall will be there? When mold cavity is present, only then mold wall we can discuss, right? So it is saying that mold wall indicate boundary within which molten material is allowed. Obviously, this is the mold wall, you will pour the molten material here. So this is defining where molten material is allowed. So this part, first half definitely is correct. Second half is while pattern wall indicate boundary where mold material is not allowed. That also is correct. How? This is the pattern wall, correct? What do? You are pouring the mold material over pattern wall. So this pattern wall, when you pour mold material, this is what you get, right? This is the mold material. This is the mold material. So what is the pattern wall representing? It is representing that when you are adding mold material, where it is not allowed, where pattern wall exists, there mold material is not allowed, right? So the mold material can stay, can come in the locations outside of the pattern wall, obviously. So this option also is correct, that pattern wall indicate the boundary where mold material is not allowed. So both of the statements are correct. This is true. Obviously, this is why when official key was not even announced, Exergic was the only institute that told you yes, A is correct. Obviously, what is the confusion in that? Thing is, let me tell you how they made option C. They did not made option C conceptually. Let me tell you, option C, I don't know how the question was made, still I can predict that how option C was made. Simply, in option A, wherever mold was written, they wrote pattern. And wherever pattern was written, they wrote mold. Entire statement is same. Only in place of mold they wrote pattern, in place of pattern they wrote mold here. As a result of which, option C has become a very nonsensical statement. Let me tell you, option C is a rubbish statement. There are so many such good concepts in casting, right? They could have asked that, but they chose to bend the option A and make an option which is very absurd, right? So that is why option C is confusing many of the students as well as some of the institutes. So option C is saying that pattern wall indicate. Pattern wall means we are talking about the situation when we have pattern right now. As I already told you, if this is the situation, it is absolutely nonsense to talk about pattern wall. Arey, pattern is not there. What are you talking about pattern wall? Pattern is gone. Only mold wall is there. So in this situation, it will not make sense to talk about pattern wall, as I told you while starting the discussion. If we are talking about pattern wall, this is the situation that we are talking about. So pattern wall indicate boundary within which molten material is allowed. What is the sense of this? You will not add molten metal to the pattern. No? Yes, there are certain types of castings where pattern stays within the mold and you directly add the molten material in the presence of the pattern and pattern melts or evaporates, right? There are two such casting methods that we have discussed. Even if you consider them, that pattern represent where molten material can come, but eventually pattern will be gone, bhai. Pattern will be gone. So if molten material is there, it has to be defined with mold cavity, not with the pattern wall. That is why the first part, obviously, this is incorrect. Conceptually also incorrect. But second part of this statement is just absurd. No meaning of it. And I told you why. Because they simply changed mold to pattern and pattern to mold. So second half has become a very nonsensical statement. Mold wall means this wall, mold wall. Let me clear it. Mold wall represent boundary of region where mold material is not allowed. What nonsense, bhai. Mold wall represent the material, mold wall represent the boundary where mold material is not allowed. Mold wall is made up of mold material. Mold wall is defined by the mold material itself. It's just nonsense statement. It does not make any sense. Obviously, this part is cavity. That is where mold material will not be there. And this part is where mold material will be there. What is inside, what is outside, how can you tell? So this part, the second half itself is a very nonsensical statement, and this is where students are getting confused, students and institutes are also getting confused. Leave it. If you think this is confusing you, leave it. Focus on the first part. Pattern wall indicate boundary within which molten material is allowed. Some students are thinking this is correct. Pattern wall indicate the boundary in which molten material is allowed, because this is the pattern wall they are thinking, in which molten material is going to come. Again I am repeating, this is pattern wall, this is mold wall. Okay? You cannot define pattern wall when pattern is gone. When pattern is gone, there is mold cavity here, there is no pattern. And that wall is now mold wall, not the pattern wall. So this is why first half is conceptually also incorrect. Second half is logically incorrect. It is illogical statement, because mold wall is made up of mold material itself. So it's illogical to say that mold material is present or not present at the wall. So that is why this C option, logically also incorrect and conceptually also incorrect. That is why C is not the correct option. Regarding B and D, I am sure you know there is no confusion. So this is why do not challenge this question. This question is a poor question, I agree. But this question cannot be challenged. Option C definitely is a wrong option. Option A definitely is the correct option. Don't challenge it. Coming to this final question, I think this was question number 55 if I am not wrong. And in this question, there's just one important keyword, just one. If we miss that, our answer will be 11,000 something. If we don't miss that, answer will be exact 9,000. You know what is that keyword? The keyword is nozzle, and this is the feed rate of the nozzle. This is the thing that you don't have to miss. Again, I am not explaining the question in detail, because I am sure we have gone through these things, the concepts of how the additive manufacturing works. So that detail I am not discussing in this question. I am only discussing the things which are required to challenge the question or not challenge the question. So here I'll give you a concept which will help you in many other places also. Look, question is asking you to calculate time, right? We know this question, I am not explaining the question. There are two broad ways in which time is calculated. Two broad ways. Whether it's the question of, you can say, fluid mechanics, right? Such concept of time calculation are there in fluid mechanics also. Time to fill the any fluid in a vessel and all, right? So whether it's the concept of fluid mechanics, whether in manufacturing, there are two broad ways in which time is calculated. Either you can calculate the time by, time calculation can be done by time is equal to total volume divided by discharge, correct? This is very heavily used in fluid mechanics, and even in some cases in manufacturing also, in casting, correct? Total volume divided by discharge, right? Remember the cases of gating system where we apply this. And the other way is very basic expression, time is equal to distance by speed. This also is used very heavily in manufacturing when we are talking about cutting processes, machining processes, right? The tool travel when we calculate. So these two expressions are very basic expression, nothing new about them, but they are broadly used to find out the time in the questions of manufacturing and in some other subjects also like fluid mechanics. In this question, what happened that many of us, when the data was given as feed rate of A by 5 mm per minute, took A by 5 as discharge, that total this volume need to be made and discharge is A by 5. So we calculated the total volume of this, divided that with discharge, right? This value directly is not the discharge, that's the feed rate, that's the velocity with which the material is coming out. To find out the discharge, you multiplied that with the area, cross-sectional area of the nozzle, and got the incorrect answer for the time, because this feed rate given is not the speed with which the material is coming out. If this question, in this question A by 5 was the speed with which the material was coming out, then the answer is correct. 11,400 something, right? That answer is correct if A by 5 was that speed. But in the question, A by 5 is the speed of the nozzle. So consider this question like a question of machining. When you have a question of machining now, where you have to do machining, tool is there, and it travels, then it is given a feed, then again it travels, then feed, then travel, then feed, then travel, then feed. Exact same thing you have to do, just you have to do that in 3 dimension. That's it. That's it. If you understood this, question is solved. And a wrong reading or wrong interpretation of a by 5 can be extremely crucial in this question. That's an important learning, right? So here, how do we solve this? Very simple. We are having a situation where from the nozzle, the material is coming out. Obviously, the nozzle has a circular area. So the material that will be coming out would be cylindrical in shape, just like the paste comes out of a tube, right? We have gone through the additive manufacturing process, so I don't need to repeat the concepts of additive manufacturing. We know how additive manufacturing works. But only that concept you need to apply with the concept that the nozzle is traveling with the speed of a by 5. So what will happen? Let me show you. So let me quickly repeat the concepts of additive manufacturing that we know. The material will be laid out in the form of the cylinders, specifically in a question like this, where you have been given a nozzle. Nozzle has a diameter, so obviously it's a circular area through which the material is coming out. So if you lay the material using additive manufacturing, the nozzle will move on a flat surface. The nozzle will move and it will keep depositing the material, just like the material comes out of a toothpaste, correct? Exactly in the same way, additive manufacturing process would be done. This is something that we all know, have covered in the unit of additive manufacturing. So it's coming out of a circular area, so it will look like a cylinder. So if you move from one end to the other, such a cylindrical shape would be coming. What would be its length? Its length would be 3a, as you can see, 3a. So 3a. And what would be its height or dimension? Is equal to diameter. Vertical dimension also is diameter a by 10, and horizontal dimension also is diameter, which is a by 10. So this dimension is a divided by 10. This travel it is doing just like you calculate the travel of tool, correct? In fact, it's very funny. It has actually written tool also somewhere in the question, I remember. Ignore any tool path motion. Other than those involved in adding material, right? So it's actually nozzle motion, but they have written tool path here. So basically the motion is similar to how the tool moves, right? So how much time it would take such a cylinder? Time is equal to distance by speed. Distance is 3a. And how much is the speed of nozzle travel? That's a by 5. So this is going to tell you how much time it will take to move from one end to the other, correct? So that's the time of a single travel. How many such travels would be required? Just keep adding layers like this, right? Keep adding the rods like this. So 1, 2, 3, 4, 5. How many? How can you tell? Total length is how much? Here also it is 3a. And one width is a by 10. So 3a divided by a by 10 will tell you how many number of such rods will be there in a plane. For one rod, this is the time and this is the number of rods required. So their multiplication will give you the total time that it will take to cover one plane, bottom plane. Picture is not over yet. It is in 3 dimensions. So one layer has been done. Up to what height? Up to a height of a by 10. Again, because its height is also a by 10. Its cross section is circular. Height is also a by 10. Width is also a by 10. So up to a by 10 it is done. How many such layers would be required? Total is 1.5a. So 1.5a divided by a by 10. That will give you how many such layers would be required. For one layer, this product is giving you the time, right? This is the time of one line. And this is telling you how many such rods, how many such lines would be required. So that multiplication is give you time for the plane. And how many planes would you require? 1.5a divided by a by 10. Total divided by height of one plane. This also you multiply here. Then you will get the total time of this volume. In a very similar way, you have to find the time for this volume. Only dimensions are changing. Process is not changing. In a very similar way, this one. Add all of them. You will get exact 9,000 minutes as the answer. Here, I have shown you that for a single line, distance by speed, distance was 3a. 3a, correct? Speed was a by 5. It will become 15 minutes. And total time for single plane, this I was calling a single plane, is equal to 3a divided by a by 10. 3a divided by a by 10 multiplied by 15, it gives you 450 minutes. And how many such layers would be required? That I told you as 1.5a divided by a by 10. So that you multiply 1.5a divided by a by 10, you will get 6,750 minutes. That's for which part? For the bottom part, right? For the mid part, use 2a and height is a. For the topmost part, a and 0.5a. So simply repeating that calculation will give you for mid part time for a single line, distance by speed, number of rods. So this product is telling you time for area multiplied by number of layers, time for total volume, 2000 minutes. Exactly same for the top part, 250 minutes. Add all of them, you will get 9000 minutes as the answer. So this question, no way it is debatable, no way there is any confusion, no way it is out of syllabus. Everything is perfect with the question. The only thing where most of us got wrong before official answer key was a by 5, that it was misinterpreted as the velocity with which material is coming out. If this was the velocity of material coming out, answer 11,400 whatever it was coming, that's correct. But since it is the speed of the nozzle, not the speed with which material is coming out effectively, that is why this process, this method is going to give you the correct answer of 9000 minutes.